All right. Hello, everyone. Welcome back to the storage thread. So this is session. Oh, I lost the session.
Session 7M.
7L. Thank you, Kelsey. This is
Yes, sir.
7L, 7M. So feel free to submit the session. If you have any questions during the presentation, ask them in the chat. And I'll hand it over to you, Kelsey.
All right. Welcome, everybody. My name is Kelsey Richard. I'm a member of IBM and I am a part of the GDPS development team. And today we're going to have a discussion on improving your RTO and your RPO with a multi-site resiliency solution. For this discussion, I will ask you if you have any questions at certain points or certain stopping points so that we can have a bit of discussion if there are any questions. But the agenda for today will go as follow. We'll discuss some of the early solutions that exploited mirroring to provide high availability and disaster recovery. We'll discuss the catalyst for change and which requirements came about that prompted us to make newer solutions. We'll also go over the new requirements for even higher levels of resiliency. We'll discuss a little bit of what's next in the GDPS solution, and then we'll have a bit of a closing. So starting off, early solutions that exploited mirroring to provide high availability and disaster recovery. So well before I started at IBM and before I was born, we had a bit of a different way to recover your environment in the event that you were to have to declare disaster. So this method was called PTAM, or the pickup truck method, access method, in which case we would have some tape storage and we would take it from our local site and we'll run it clear across town to our disaster recovery site, load it in, and IPL off of that data. With that being said, the recovery point objective at that time could it would increase significantly because during the time that it took to drive across town, the time to get the information loaded, the time to IPL, you were moving quite far away from the point of objective that you had, your recovery point objective that you had. Sometimes you could be 24 hours past it, you could be 48. It just depending on how much when you took that last copy of data to tape. And not only that, because you're hauling the tape to the opposite site or your DR site, your recovery time objective would greatly increase because with recovery time objective, that is the time it takes your business to become operational, and it will significantly increase with you having to unload, load, and IPL something. Now, around the late 90s, a new mirroring technology was introduced where we had this mirroring technology was synchronous mirroring from your site one disk to your site two, and it was dictated by mirroring latency now. Instead of how many frequent backups you took, now it was dictated by the latency, meaning that we mirrored our information from your disk in your local site to your disaster recovery site. And with that, the recovery point objective could be minutes, hours, just depending on how many times you decided to take a backup of that data. In addition to that, we significantly reduce your recovery time objective as well, because instead of having to haul tapes to your DR site, you're now able to just restore your entire production environment from the tapes that are already there at your DR site. So this mirroring technology was known as a synchronous mirroring technology, Metro Mirror. And we're going to get into how GDPS applies Metro Mirror in our environments to reduce recovery point objective along with recovery time objective. So to give you an understanding, GDPS is a solution of offerings that come together to create a near to provide continuous availability, to provide automation and recovery in your environment. Is a solution that gives you a single point of control to monitor your environment, and you also receive reports in your environment if something is going on. GDPS is it manages Your Sysplex, it manages your server, it does server management, storage replication management, recovery management. And with GDPS, you can actually automate and create automation to provide you with disaster recovery with your disaster recovery solution. So with this automation, in the event that you need to declare disaster, we have repeatable steps that you could have implemented well before the disaster occurred to practice what would happen in a disaster. So it removes the manual aspect of it. Now, with GDPS Metro, which is the data, it maintains 3 copies of data synchronously replicated in your environment. You can have 2 to 3 data centers, 2 server sites, and 3 different disk locations. This solution or offering under the GDPS umbrella allows for continuous availability because we're always synchronously sending information to our DR site, whether it's from a single data center or to 2 data centers. We're able to do this over a metro distance. In addition to that, we also allow for disaster recovery practices at a metropolitan distance. So as part of the discussion, we're just trying to figure out how to slowly lower our RTO and RPO. And as we go along, this solution works out because it manages your environment at a single point of control. It reduces your RTO to about 2 minutes for multi-site workloads. And then it also reduces your single site workloads to less than an hour. And you have a recovery point objective of 0 because the data is already at your DR site. But then we thought, hey, let's add a little bit more to this. Well, there's another form of mirroring technology, which is global mirror technology. So we created the solution known as GDPS Global GM, which is global mirror. And this is disaster recovery at an extended distance. So clients said, we need more space. We need to be able to recover at a larger distance than a metropolitan distance. So GDPS Global GM came about. This technology, similar to Metro, it allows for monitoring of your environment as a single point of control. But with this solution, it supports an RTO of less than 1 hour and an RPO of as low as 2 seconds. This is this allows us to have 1 copy of data in region A and 1 copy of data in region B. And utilizing asynchronous replication, we're able to replicate data quickly across a large distance and to our DR site. So in the event that you have to declare declare a disaster, you're able to, you already have a copy of data in region B, which should be further out of the disaster region. This and all GDPS offerings are scalable offerings. So let's see. If you have any questions or you want to make a comment now, you can. If you have any questions right now, just let me know or put something in the chat. If not, we'll continue on to the next part of the discussion. All right. So we have GDPS Metro and we have GDPS Global GL. We have replication between a metropolitan distance, and now we have replication at extended distances in a disaster recovery solution. We have continuous availability with the metro side of things, and we have a disaster recovery solution with the global mirror technologies. Now, a lot of clients was like, well, in the late 90s, early 2000s, a lot of clients realized that the metropolitan distance is not enough. One of the catalysts for change would have been September 11, 2001, when the American trade centers were hit. Legislation came out and said, well, after the trade centers were hit, a data center went down, it could have caused a problem with commerce. Well, how can we fix this? What can we do to allow the economy to continue to go in the event that something were to happen? So they came up with these two requirements: maintain sufficient geographically dispersed resource to meet recovery and resumption objectives, and routinely use or test your recovery and resumption arrangements. So in a nutshell, this just means we need to have a more geographically dispersed solution. This solution should go further than the region, than what we have for Metro Mirror. It should go further than what we have Global Mirror. And not only that, we need to be able to prove that in the event that we have to declare a disaster event, that we're able to bring up operations in our recovery site and maintain work over there. And that brings about the new GDPS, one of our newer solutions, the GDPS Metro Global GM3 site, or MGM3 site as it's known. With this solution, we now have a cascaded environment, meaning we not only use synchronous technology to replicate from the Metro Mirror side on region A, we also have a global mirror from region A to region B, allowing us to have similar copies of data throughout our environment. So you can have 2 or 3 data centers available in this configuration. You now have high availability on the Metro Mirror side, while also having disaster recovery for regional distances from region A to region B utilizing global mirror technologies. This significantly reduced our RTO and RPO. So for a local failure event, your RTO is less than 1 hour and your RPO is 0 for local failure events. But say if you have to declare disaster and you have to go from region A to region B, your RTO is now less than 1 hour and your RPO is as low as 2 seconds to get up and operational in your disaster recovery site. But with this solution, there's still a problem. So let's go through some scenarios on how GDPS GM3 site would work. So one thing I did not mention about Metro Mirror is that it allows us to utilize hyperswap capabilities. Hyperswap being when you have RS1 devices and RS2 devices, this Metro Mirror leg. In the event that you have to declare a primary failure, you are able to swap to your RS2 devices, and you're able to promote host IO on your RS2 devices in a Metro Mirror configuration. That is one of the biggest methods of utilizing Metro Mirror, is the hyperswap capability. So with hyperswap, while running in a cascaded environment, one with a Metro Mirror on your region A from RS1 to RS2, you have host IO taking place on RS1. You have a Metro Mirror replication taking place between RS2 and RS1. You have a global mirror going to region B, RS1, and then on region B, you're able to take a global mirror flash copy, which is a point-in-time copy of the devices in region B at that time. So that is a cascaded configuration. Now, in the event that we were to perform a hyperswap on the Metro Mirror leg, you would suspend Metro Mirror right here, and host IO, instead of taking place on RS1, would now take place on RS2. Your global mirror relationship between RS2 and region A and your region B RS1 devices stays the same, and you're still mirroring over there. When Metro Mirror suspensions takes place after or during a hyperswap, a freeze is initiated, which drains information from your RS1 devices down to your RS2, making the devices similar to one another at the time that the event or failure has taken place. After that, you would like to resync your Metro mirroring to bring back your high availability. So with that being said, you're now still running host IO on your RS2 devices. You'll resume your Metro mirroring from RS2 to RS1, and you'll still have that global mirror relationship, and eventually all the devices should sync up again. Now, say in the event that you you have an MGM3 site topology and you lose your RS2 devices. So similar to what we've already seen, you have host IO taking place in region A on RS1, a metro mirror going to RS2, and then you have a global mirror going from RS2 to region B on RS1 and a GM flash copy. You lose access to your RS2. You're no longer able to write. Something has happened. Mirroring is suspended. A freeze takes place. And your RS1 is still having host IO take place. So under the covers, you have already implemented this, created the scripts, and you've implemented the procedures to make sure that in the event that we lost RS2 or we lost access to the RS2 devices, that something will happen under the covers with GDPS, some scripts, some workflows, whatever you have created as the client and tested will take place, and it will initiate a sequence where you will initiate global mirroring from your RS1 where your host IO is taking place. And this will allow us to incrementally resync RS1 to be a copy of region A's RS1. And then whenever that's done, you can also create a global mirror flash copy or a point in time copy of the devices at that time, just in case you ever need to IPO. After that is done, just like we did last time, we will resync our metro mirror relationship. So IO is still taking place on RS1. We still have our global mirror relationship going from RS1, ARS1 to BRS1. But now we have a metro mirror relationship going from ARS1 to ARS2. And that allows us to have our high availability and our disaster recovery at a distance as well. So, any questions from what we went over so far? Okay. Moving on. So, requirements became more stringent. We have high availability, we have disaster recovery at a distance, but clients are hesitant to declare disaster recovery. And I'm sure you could figure out why when you look at a GM3 site environment, which is one of the best environments you can have. So DR testing was not providing sufficient confidence that you could run peak workloads in your DR region. And then the financial sector said, hey, we need to encourage regulators to make companies prove that if you have to declare disaster, that your DR region could handle peak workloads and demonstrate the ability to return home after the event. This is called region toggle, or AKA switch and stay. So let's go back to the GM3 site environment. With this environment, you can see that we have region A, which has a metro mirror. That's great. We have continuous availability locally. But then we have, for region A to region B, we have a disaster recovery at extended distances, utilizing the global mirror technology. With this solution, if we were to lose our metro mirror side, or we had to declare disaster, we will only have one set of disk, only one copy of disk. We will have no high availability file storage. And then not only that, what makes a client believe if we only have one set of disks that they could run in this configuration? So this brings about a new GDPS topology known as GM Foresight. So we've come a long way. This is all disk-based replication, but with MGM Foresight, you can see the difference between Foresight and 3Sight right here. We now in region A have a similar setup in region B. We have now moved from, we now support an RTO of less than 1 hour and the RPO as low as 2 seconds. We still utilize powerful scripting commands to automate recovery operations. We have a metro mirror taking place in region A. We have a global mirror going from region A to region B. And then we have a global copy in region B. Now, the best part about GM Foresight, it is a symmetrical configuration. It provides the same levels of resiliency in region A as it would in region B. In the event that a client needs to declare disaster, they're able to go to your region B, and you're able to do peak workloads in your region B because everything is set up the same. You have the same fiber, you have the same switches, the same routers, everything is the same. It is a mirror of one another. So let's take a look at how it would work in a MGM Foresight if we wanted to do a planned region switch. So to start off, just to orient a little bit, we have region A up here. We have some productions, we have some controlling systems, some disk, etc. Your coupling facility region. This is your metro mirror in your region A. So your RS2, you have your KPA2, outpar, you have production. We have a region B set up similar to region A. So in region A, we have a metro mirror instance going from region ARS1 to ARS2. We have a global mirror going to BRS1. And on BRS1, we're taking a global mirror flash copy. And then on BRS2, we have a global copy taking place. So the first thing you would do in this instance is bring down your production in KPA2. So as you can see, it grays out. These systems are still a part of the Plex, but they are not, they're now inactive. After you do that, you're going to run some workflows or some scripts for, and it's going to be a single script statement. And it's going to say procedure equals MGM Foresight switch CAS1 to RS1. So with this single script statement, you're going to stop your global mirror relationship from region A to region B. This will allow us to drain the data. And once the data has been drained, this means all 4 copies in your environment, they're the same now. We're going to switch our metro mirror to a global copy. Now we're doing a global copy between ARS1 to ARS2. And then in addition to that, we're going to switch our global copy in BRS1 to BRS2 to a metro mirror instance. Then we're going to reverse mirroring from region B to region A. And now we have a global copy, and it's going to utilize the GDES, the initialized workflow. After we have initiated that, we will bring up our production. So in region B is now the main, we're in region B. Production is going to come up on KPB2, which is our part right here. And that would be the way to do a planned region switch for MGM Foresight. This region switch could take less than an hour. So you'll have an RTO of 1 hour or less. You'll have full capabilities in region B that you had in region A. And if in the event that you wanted to say, hey, I don't want to do this full planned region switch, I think I want to stop, you could stop it right here. You could have stopped it at that point. You could just continue to have mirroring take place with your global mirror pointing to from RSA for region A to region B. So any questions or anything in the chat? Not really keeping an eye out, so.
No, nothing in the chat so far.
Okay, well, since there's no real questions, I'm probably going to end up finishing a bit early. So we'll go over the resiliency requirements and how they continue to become more stringent and the things that came about from there. So with these resiliency requirements, as we've already discussed, GDPS Metro provides us with continuous availability, but at a metropolitan distance, okay? So clients need unlimited distance between sites for protection against regional failures. That's what they came up with after Metro. So what did we do? We introduced GDPS Global. We provided disaster recovery at unlimited distances, but it didn't have that the continuous availability part of it. And then when you're switching your entire site, it will impact business operations, and it takes over an hour to become fully recovered. So after this solution, clients was like, well, we need the ability to switch a failed workload or all workloads in less than 30 seconds. And then not only that, we need to keep our critical workloads available during planned outages. They really just wanted to have RTO of seconds across unlimited distance, which is not possible with the traditional failover methods that we've already gone over. So with the methods we already talked about, we utilize synchronous or asynchronous replication, disk-based replication. But we need something different. We need something that's at an unlimited distance. We had metropolitan distance, we had extended distance, but now we need something at an unlimited distance. And with fiber connectivity, it would not happen. So that's when GDPS came up with continuous availability. So GDPS continuous availability, sometimes known as active, allows for near continuous availability at an extended distance. This means you have two distinct sysplexes performing work actively. With that being said, up here in this cloud is a cloud on the picture, but just picture it as having switches, routers, and etc. that sends the workload to whichever sysplex it needs to go to. Not only that, with continuous availability, we have significantly decreased our RPO and RTO. We've gone from minutes to hours, and now we're down to seconds. RPO is now 0 to 5 seconds, and now RTO is between 20 to 30 seconds. And this is done utilizing software-based replication. So within this little cloud right here, where we have our routers and switches that point our workload to each sysplex. If a workload fails, we can actually control and switch the workload to a different plex and continue to work there. So we have near continuous availability. We're able to facilitate better regulatory compliance management. And not only that, we're now at unlimited distances because of the software replication. We've moved away from asynchronous replication. We've moved away from synchronous replication and disk-based replication. Now we're at software replication, and we're able to replicate data from sysplex A to sysplex B utilizing routers and switches. And not only that, GDPS still continues to do what it needs to do under the covers. And that is, we still manage all of your environment from a single point of control. You're able to still utilize and automate GDPS scripts to manage your environment if you have to declare disaster. You're still managing your sysplex. GDPS still does this, but now we're doing it at an unlimited distance. So, what's next? Any questions, comments before we get to the what's next part? Right. So now we introduce a new topology within GDPS. This topology is known as MGM6 site. With this topology, instead of having just a single Metro mirror instance like we did at MGM4 site, we now have multiple copies of Metro mirror instances to take place. In the event that we declare a primary failure, we're now able to hyperswap using Metro Mirror technology. We're able to hyperswap from our RS1 to either RS2 or to RS3, allowing us to have 3 separate copies of data in each environment. Clients have come back and said, we need to have more than 1 copy. If we only have 1 copy of data in our Metro Mirror environment at an Metro Mirror environment similar to how MGM Foresight was set up, then that's bad. What if we lose that 1 copy? Then we have to declare disaster. But if we have 2 or 3 copies of this data in one region, then we don't have to declare disaster. We could just hyperswap to the opposite leg, IPL off of those devices, and still keep region A available. But if we lose all the copies in region A, we can now declare disaster and go to region B, and we still have 3 copies of data in region B. And that's how MGM 6 site came about, because we needed more copies of data. We needed more redundancy. We needed just a little bit more so that we didn't have to declare disaster in the event that we just lost only 1 set of disks, or we were down to one set of disks. Now, with this new solution, we have 3 sets of disks in each region. So, closing, any comments, questions? All right. So, year to date, so this is at the end of 2023. As we can say, GDPS is a solution that offers repeatable and automated scripting functionality and workflows that allows your system to automatically recover in the event that you have to declare disaster, or in the event that you have a primary or PPRC failure. You're able to have multiple copies of data in your either your RS1 or your region B site. GDPS provides you with the confidence that you've already tested these solutions in your test environments before you had to do it in production, or before the disaster happens. It is a solution that allows us to prevent or to answer to a disaster if need be. We not only provide a solution of high availability, but we also work with cyber resiliency as well. GDPS has gained significant traction in the works of GDPS logical corruption protection. We provide automation, monitoring, and management of our safeguarded copies, and we've sold plenty of features to clients within the last 5 years. GDPS is found at 83% of the top 40 banks around the world. And we just manage the entire Sysplex from start to finish. And many of our clients are actually moving from MGM 3 site to MGM 4 site as well, to get that redundancy and to get that symmetrical configuration that allows for switches, stay, and site toggling. So this is a bit of additional information if you want to learn more about GDPS, or you want to look into some more information. If you have questions, you can ask them here. We still have a bit of time. However, if you have more questions and you want to ask us and we're not here, you can email us at gdps@us.ibm.com. And we also have some publications that you could check out to learn more about GDPS as well. So this is the session feedback information. The session code is 7M. That QR code does work, so please check it out if need be. Is there any questions for me? I want to thank you for coming to the presentation. So if you have any questions, please ask now. If not, you can also email us at that email. Thank you.
Okay, thank you very much, Kelsey. So as you mentioned, the session code is 7M, so fill up your feedback. If you have any questions, please reach out to Kelsey, and thank you very much for the presentation. And this ends our storage track for today. So thank you again, and see you tomorrow. Take care. Bye-bye.
Bye.